And good afternoon. Welcome to the second of this semester's security seminars. Today we have a presentation from the newest full-time employee at CERIAS, Pascal Meunier. Pascal originally did his PhD in biophysics, and while at Purdue took a security course and worked on a project involving singing passwords as a way to remember them. The idea was very intriguing. He got really hooked on the idea of information security and has been with us ever since. When he completed his master's degree, he joined us and is now one of our staff scientists and is in charge of our technology park extension. And today he's going to talk to you about one of the projects he's been working on over the summer, the CERIAS Incident Response Database. So please join me in welcoming Pascal.
Thank you. So this project is a database for gathering costs and incidence information on types of security events. The problem that this is trying to solve is how to collect accurate data about the cost and the frequency of types of incidents. And that brings the problem, how do you classify incidents? Survey of different universities found that they were all using different classification of incidents. So when they tried to analyze the data and gather it and assemble it into a coherent whole, they found that it was very difficult to do. So what is the solution? One approach would be to force the adoption of a standard classification that everybody would adhere to, assuming that you can come up with one classification that is appropriate and correct for everybody. The other way would be to provide a mechanism through which you can translate classifications. Another problem is how can such a database help administrators find the cause of the incident? The only symptom you may have is that your process died or the machine crashed or very vague details like that, or you may find that somebody has left a rootkit in your machine and so has corrupted the various mechanisms to log in and to record events in the machine. So from that, where do you go to look for the way they went into your machine and broke into it? Another problem is how to support incident response activities when there are many people involved. For example, you may need expertise from someone at CERT to resolve a problem. And at the same time, you may want to assemble an archive, complete archive of the incident for later analysis. And on top of it all, how do you do that in a secure manner while protecting information from other people who aren't supposed to see it? For example, at Purdue University, if there's an incident in CS, maybe they don't want people in biology to know about it, or vice versa, and versus departments would want to protect the people involved from other people who shouldn't know. So here are the important players in this area. The first is the CVE, it's the Common Vulnerability Enumeration. It's a tool that gives a tag name to all publicly known vulnerabilities. It consists of a board of editors that reviews the vulnerabilities and votes on them as being properly described. And the list is accessible here at this URL. Another useful tool is the ICAT database by the Computer Security Division at the National Institute of Standards and Technology. The difference between this one and the CVE is that it provides cross-references and information on patches, and it's also searchable by a variety of criteria. Another influence is the ICAMP project and the 2 reports that they've produced. I cited just a moment ago one of their results when they were looking at the classification and use at various universities. They are the one who did the pioneering work in trying to find out which vulnerabilities happen most often and how to analyze their costs. And then there's the SANS organism for System Administration, Network, and Security. And you can access it at this URL. One of their important contributions, for example, is the top 10 list, which is the list of the 10 most often exploited vulnerabilities. Actually, it's also categories of vulnerabilities. Just a little bit more about ICAT. As I said, it's searchable by various criteria, which are very close to a classification. It provides very useful links also to other databases. And it contains most of the CVE records, and they have the goal of having all the CVE database classified and accessible there in a relatively short amount of time. We're talking about in a month. They provide actually they will provide shortly a classification by which you will be able to find CVEs by the kind of attacks that they will allow. For example, penetration of the type root access, or for normal users, or other types of penetration. DOS is denial of service attacks. And recon would be like just probing your system, trying to find out what services are running on it, so as to mount an attack later. Now, an important observation that I made early on in the process, and that is inspired by the people who worked on the personal software process. People familiar with software engineering will know that the personal software process is a way of recording the time you spend on various activities so you can improve your programming and your software skills. Well, this very important observation is that the reporting on your activity has to be done on the spot as it happens. Otherwise, if you try to do it at the end of the day and recall by memory, you will get it very wrong. So I concluded that it would be very nice if the incident report database would support real-time response to incidents. So we built this as a web-based database, in principle with one repository per organization. The advantage is that it's accessible all the time, from any incident, anywhere, any lab, any machine almost. Alternatively, if you're a small company and you don't want to mess with installing it and you trust us, then we could give you a domain in which you could work and in which your information would be protected. Other advantages is that if you're looking at the incident response database and wondering if you want to deploy it, then you can remotely look at it. The web brings other advantages. For example, it's platform independent. You can look at it and use it on Unix, Windows, Macintosh, anything. Another important advantage is that you can cooperate with it remotely with other experts. You can share the data and you can have them not like a chat, but you can make your data visible to each other and interact that way. Another advantage is that the statistics about what happens can be, or could be remotely accessible if you allow them to be. Disadvantages, of course, are that, well, if your network is down, then you won't be able to use it. And in addition, the scheme I used, well, yeah, you can't get easily away from the passwords, user passwords. So if you use weak passwords, then if someone can guess them, you're vulnerable. The way it works basically is that through SSL, a user would give his password to the incident response database and then would get in return a cookie with a random number that we call a nonce with 20 random character. And then whenever you ask for a web page, the database asks for the nonce back, and because it's a huge random number, it's very unlikely that anybody else can guess what it is. So if you give me the right nonce, I will conclude that yes, you have access to the database and you are who you say you are. The problem with that is that you have to trust the computer on which you're working. So it might be a better idea not to work on the computer that's been compromised. And often cookies may live after you've closed the session. Let's say you log out or whatever, the cookie might still be there. So in order to control that, the database makes the cookie so that they expire after 24 hours. And it also sends a command to the browser so that the cookie is overwritten when you log out of the system. And in addition, when you log out, the IRDB remembers the nonce, and if this nonce is ever sent back to the IRDB, then somebody will, the IRDB will notice that, well, it's already been used, it's invalid now. The session is finished. Now, I'm going to talk a little bit about how the database works and how it's constructed. You've got different domains for every entity that wants to use the database, and inside it you have plenty of incidents. Now, a user can have access to a domain with various levels of privileges. Administrator means that they can access everything and modify everything. Auditor means that they can read everything. And submitter means that they can start incidents. Researcher would be me, for example, if I want to know in your database what has been the cost of denial of services attacks on your organization recently. That is, if you allow me to have access. And then if you want to share data, let's say that I take you as an external expert. And then I say in my incident I want to allow all external experts to read the incident, then you will be able to access this incident only. And that way I can have you help me without having to show you everything that's in the database. Okay, just a little bit more on what happens to the incidents. Basically, you enter them, they're new, somebody will take charge of the incident, going to work on the incident, and then the incident is going to be either resolved or it's going to be rejected because, I don't know, it didn't make sense, or there was not really an incident underneath what happened. Okay. Now the costs. How do we know that an incident is really important, or that it's really, or that we should devote a lot of research and efforts in solving a problem? Is that, well, one way is by how much it costs to have these incidents processed. also for general management. So there are two types of activity you do with this database. General activity, just looking around, searching, and then responding to an incident. So as I was saying with the personal software process, it's nice to have the machine do the accounting for you. So as you're working on the incident and doing stuff, the machine will keep in memory how much time you spent doing what and going to switch between those modes. And then there are other types of costs. Of course, you want to include the overhead and the actual cost multiplied by the duration. Then there are raw costs. For example, if equipment was stolen, then the cost of replacing it, and so on. I can't help a lot in establishing these because they pointed out, for example, that, well, if you lose the opportunity of doing one thing, then you might be able to do something else in the meantime, work on a different homework or a different report or whatever. And then you may be willing, maybe you're working on this homework that's due in 2 hours, and you may be willing to pay $100 to have the service back. So that would be the willingness to pay. Now we're getting to the more interesting stuff from the point of view of research. That is, what's a type? And what is this incident actually? What do I do with it? Is it sufficient to say that it's a mail bomb or it's a denial of service attack? So the way I went about it is that I made two types of classification, two levels. There's a risk type, that is what can happen as a consequence of the incident, and then the attack type, which would be, for example, one of the SANS top 10. For example, that would be the use of weak passwords with well-known user IDs. This is the way it looks. For each attack, you can have one risk type. And every attack has a risk type. And the attack may correspond to several CV entries. This is an attack types. Some of the entries in the SANS top 10 have more than a dozen related CV entries. So vulnerabilities that can result in that. So the attack type dictates the risk type. But as you're responding to the incident, maybe you don't know yet what was the attack that was used against you. So you can specify the risk type independently of the attack type. But then if you identify the risk type, because of this relationship, you can ask the database, what are the attacks that could have done that? And then you may look in the CVE and say, well, no, I don't really have that on my system. And by process of elimination, then you might be able to find out which vulnerability was exploited. Now the interesting part is that I made the types dynamic. That is, instead of trying to find a classification that would answer everybody's needs, you can change the classification. You can change those types. And the way we'll understand each other is that I classify the types themselves. Let me give you an example, and maybe it will be easier that way. For example, in company A, they may call something a root break-in. Company B, they call this a classified root crack because they might have classified and unclassified computers. And in C, well, that is also part of B. They want to distinguish between the root cracks in classified and unclassified computers. Now, if you notice, they all have the same consequence. They have the same access type, that is, they can list, read, write, execute files, and the privilege type is root. So I can query the database, and no matter how you name the risk type, I can request to, well, how much did the incidents that involved account access of privilege type root cost, or how many were there last year? So this is the rest of the classification of risk types. There's a consequence. For example, exposure, that is, you're leaking information to an enemy, or service loss, that would be a denial of service, or service theft. There's also the access type that you gain, which is of course relevant mainly if you have account access. And then the privilege type, which also refers mostly to account access, but it might be that you executed commands with one of these privileges. For example, when there are some vulnerabilities of web servers that allow you to execute commands with the privilege of the web server. And then there's a priority assigned to this. The priority is really to help system administrators find out where they should direct their efforts first. And with this, you can also differentiate things based on the priority you want to assign them. For me, a denial of service coordinated, that means like the distributed denial of service, many computers are coordinated to attack together on one target. And if you want to distinguish between that and denial of services that are uncoordinated, that is one-on-one, you can do so. You can make types to distinguish those, but then by accessing the underneath classification, then you can find out more general properties. Okay, so you've got an incident and you've worked out what happened a little bit during the incident, and you want to find out what was the vulnerability that was used to plug it in, to close the hole. So there are two ways that you can do it with this incident response database. The first one is, if you know the risk, then you can query the database for the types of attacks, and from the types of attacks, then you can get CVE entries. The other way is from knowing the risk and doing a little bit of manipulation on the data of the type that I was just talking about, then you can translate that into what ICAT understands. If you can specify the operating system on the host and the software and the version they're using, then you can make a query on ICAT, and ICAT's going to give you all the CVE entries that are relevant to it. Of course, that assumes that the vulnerability is publicly known. Well, I've been talking mostly so far about technical incidents. I'd just like to point out that there's also human incidents that use technical means to be done. For example, if you send anonymous death threats, or you harass somebody, or you're storing child pornography on your computer and maybe even distributing it. All these incidents also have their classification in the IRDB, and it's also necessary to respond to them. So all the methods that are discussed so far, except using ICAT or the CVE, applies to this. For example, you can make your own type classification, and I'll be able to go into the database, into your database, and take out the information that I want. conclusion, the incident response database is designed to be used during an incident, by contrast to reporting after the incident is closed. The database system calculates the time you spend in each incident to help you calculate the cost of the incident. You can also add other costs. The classification is flexible, so you can have it adapted to your needs. On top of that, the classification through the underlying type classification can be translated. Then the IRDB provides some mechanisms to search other databases and access other resources, help you find the cause of the incident. And then finally, you can share the data. You have timestamped archives, and because there's email support also in the database, you can send email and receive email. That provides you with the opportunity to have a complete record of the incident. And then we can have this precious statistical data about what actually happened and where efforts should be directed.
When you talk about the status and the distribution of it, the status of the next, what are you doing next?
Well, we're finishing currently the first version of the IRDB. We have it. We have a few people testing it and using it. Of course, the incident that dwarfs all others is port scans, just people trying out to break into your systems.
Can I do a scan on you?
We hope to have it adopted, of course, as widely as possible, because the more people are using it, the better the data will be, and the better the research will be able to accomplish out of it. Right now, anybody can request a domain to try it out in the server we have in CERIAS, and as soon as the comments and criticisms slow down, we'll be able to have a good version to distribute. And well, I hope that in the next month we'll be able to distribute it. So, time frame of October.
Anybody have any questions?
Behind you.
If you don't have questions, who's going to do it again in French?
Okay, so you've used the terms exploit, attack, and vulnerability pretty much interchangeably. Do you make any differentiation between?
Can you repeat for me?
You're using the terms exploit, attack, and vulnerability almost interchangeably. Are you making any differentiation?
Oh, yes. Yes. Those are terms that have various meanings to a lot of people. It is confused also by the CVE, because the CVE describes vulnerabilities by the effects that they can produce. If you look at the current CVE, what you find actually are description of attacks, because they don't want to give out the exact information about the vulnerability. And then you have to think, well, the vulnerability they're talking about is the vulnerability that can produce this attack, or the vulnerabilities, plural. So there may be several vulnerabilities that are exploited in one attack. An attack can be an exploit the same way that an attack can be successful or not. I call exploits successful attacks, but they also have the meaning of scripts that people can use to attack.
I mean, for the purposes of the database, are you making any differentiation, or does it not matter? Is that not?
Yes, yeah, okay. For the database, vulnerabilities are completely separate from attack. Actually, you go from risks to attacks, and then you can find out which vulnerabilities can have caused the attack. But I do not make any distinction between an exploit and an attack. Actually, in the database itself, I try to avoid the use of the word exploit. I just use attack.
You use the term incident, and what do you consider an incident? And then more specifically, what is a rejected incident?
Okay, an incident is basically anything that can generate a complaint to a system administrator or to computing services. That's why I distinguish between human and technical incidents. Human incidents are those in which the meaning of the data is meaningful, is the dominant aspect. By opposition to technical incidents, in which it's actually the protocols or the codes that are made to work not the way they were supposed to work. I'm not sure that answers your question.
Well, let me ask it. If I install Windows 2000 and get a blue screen, does that constitute an incident if I report it?
Yes, it does. It does. Now, if it's right. I mean, I can reject it by saying, well, there's nothing I can do about it because it's something that's frequent on this system. Maybe not 2000. I don't know about 2000, but let's say Windows 3.1. I can just dismiss it, or I can investigate it. If I dismiss it, then it would be a rejected incident.
Or you could send somebody out to replace it with Linux.
That's right. Yes.
Pascal, in your data type classification examples, you used the priority code to differentiate between two types of entry.
That is, it's an option that you can use on your end. It's not something that I really care about.
Right.
That is for the system administrator.
My question is, do you have any other fields or any other provisions within those data types to differentiate between those two types of attacks that you mentioned? Or is it merely the priority code that differentiates the two?
Okay, it works this way. Let me get just a
Pad underneath.
No, I'm committed to acetate technology today. So if this is a record for an incident, actually I mean for a type, then each type has an identification number. So that's the primary key of each type. Then they have a name, which is meaningful for the user or the administrator. Otherwise, inside here there are a few more fields like I showed, and then the priority. From my point of view, you can have all these exactly the same, and it doesn't matter to me because when I'm going to query, I'm going to specify these, and then I'm going to get all your types that have the same values in these fields.
I guess I would be wondering from a user standpoint, if you've got so many fields that are similar, is this naming scheme then just merely an enumeration of various classifications, just differentiated by the priority code?
I tried to make it so that these fields would be as meaningful as possible. Yet I wanted to be as small as possible also. It's a trade-off between the usefulness for the end user and the complexity of the system and the classification, and also which data we would like to get out of it. I don't take these as fixed yet, but from the other database that I've looked at, for example, ICAT and other companies, those are the most meaningful ones and the most likely to be useful. Now, if you want to make other differences on top, it's up to you. And if those differences are adopted by a number of people, then it might be interesting, in effect, to migrate the difference into the internal classifiers. Yes?
You mentioned about the importance of the real timeliness aspect of your system. How did this affect your decisions while designing the system?
On a number of questions of technical implementations, I made the web pages expire as soon as they were served, which means that the navigation doesn't work anymore with the back and forward buttons on the web browser. Everything has to be done with buttons, so that, and every time the new page, a fresh page is generated, so that every time up-to-date information is served. Now, there's a fundamental problem with web technology, in the sense that unless you use fancy protocols, fancy gizmos, it's mainly a pull protocol. That is, I'm not going to get updated information until I request an update on the database. For example, the main page of the system has a number of indicators that turn from green to red when an event happens. Well, if you just leave the web browser open, there's not going to be any change on its own from the way it's implemented. You could view it as a defect, or as a possibility for later improvement, in the sense that if it was possible to make the web page update itself. But the approach I've chosen is to, in the underlying system, connect it to email. Now, you could say also email is a pull protocol, but in most cases, people have their email client pull repeatedly the server, and as soon within a certain interval, if a new email comes in, then there's a notification. So within the polling interval of the email system, you would get a notification that something important happened.
I'm not very familiar with how this works, but aren't there, can you do server push pages or automatic refresh for this type of things that you just mentioned?
Yeah, you can. It's just not implemented yet in the IRDB. Yeah. You could force the refresh at certain intervals. Yes.
Why don't you start the web browser to show people the front end of it? Can you do that?
Yeah, I can access it from here, I guess. Let's try Netscape. Sorry, we use SSL. I forgot to put the little S here. Okay. So this is the welcome page. Now, apparently, sorry, I've been a little bit paranoid in the design of this system, and I've been keeping up to date with the browser bugs. So I'm sorry that I can't show it to you this way, unless it's got Internet Explorer software installed.
As soon as I need it.
Oh yes, there we go. Okay. Now, can I enter my password without the video showing it repeatedly so people?
Now you can.
All right. No. Don't remember my passwords. Okay. Now, apparently I forgot to log out the last time I used it, and it reminds me and asks me when I actually finished my work. We'll say 11:15, and this illustrates the point I was saying. You try to remember later on, you don't know. So here we have a listing of domains that can be accessed. I'll use the biology domain because I've had permission from the system administrator to show some of the data here in demos. So depending on the level of privilege, you have different rows of actions that you can take. Everybody can do these actions, that is, change their user informations, see the incidents in which you are involved, that is, if you play a role in an incident, and you can look at the general management costs so far that you have incurred. If you're a researcher, you can look at the cost so far of incidents by type and by operating system. Here's a page to manage attack types and risk types. For example, I can ask to show the attacks that result in a penetration attack, and here in the menu are the types of attacks that can result in a root penetration. These are all in the SANS top 10. And I've also human risk types. These are sorted by the priority I give them. So if you change the priority, for example, you think that you work at the Recording Industry Association and you think MP3 is a capital offense, you can modify its priority. Let's give it to 99 here. Of course, it affects copyrights as a theft of multimedia data. And now we have MP3 trading as the most important type of human risk. Now let's go back to the main menu. If I search for incidents here, I can specify a number of criteria. If I don't specify any, then I get the entire list. And you will see here that most of them are port scans from various addresses, a couple from Korea. And the owner is our good friend tester Dwight McKay. And then we can look at this incident. Notice the incident as a random number because you can send email to the database, and it's the same idea that you make it big enough that it's hard to guess. So very few people will be able to send unwanted emails to the database. So record the information. I can grab the ownership of the incident if I want to, because I have administrator privileges. The technical risk is recon, and there's no operating system associated with it because it's a network event. Can specify a CVE entry and reclassify it, for example. This should be a port scan. And now the classification here has been changed to port scan.
So is this updating the account for this particular entry? The
Yes.
time you're spending on it?
Yes. The time is counted as I'm working on it.
How does it determine that you're working on it?
Because I'm logged in and I haven't logged out yet. And the last page that I requested was to work on this incident.
Okay, so when you entered this incident, that's when it started timing for your work on it.
Right. For example, when it started counting, now it stopped counting on that incident. But when I searched, here I displayed the results, and the moment I click here, it starts counting the time as being assigned to this incident. So as long as I think about this incident, or that I view email on that incident or respond to email, it's assigned to this incident. And so far, I can look at the cost. Well, the cost on that incident isn't much. I guess he's been very quick in answering it. And I can look at how much time I've been spending on the database so far, and how much it's worth. And I can add additional costs. Let's say we've got to replace a router or something like that, then I can add another cost here.
So is there a way for them to pause? Like, for instance, they get a phone call.
Good point. Version 1.01. Yes.
What's your database backend?
Currently it's MySQL, but we're thinking of migrating it to PostgreSQL. The reason is because MySQL is in such widespread use that we thought it's so exposed, if there were many bugs in it, they would have been found so far. And it's also really easy to set up and use. Of course, it's very performant. On top of that, it's free, so if we distribute this system, then we don't have to pay royalties.
From modifying the database directly? If they've...
It's on a dedicated server.
What?
It's on a dedicated server. And of course, the database itself has access permissions and so on. If you mean through the web interface, then of course there's a domain mechanism as well as the role mechanism. That is, if you don't have any privileges in one of these domains, they're not going to be listed at all as options. And even if you were able to engineer a query to submit to the web server, of course the database checks everything before allowing you to do anything. I mean, let me rephrase that. The PHP scripts that program and encode the logic of the database would first check the database to verify that you have the right permissions, and would deny you access.
Another database question. Do you log every transaction on the database, every change? So that I can, if I had an incident and I wanted to follow it and I wanted to see if someone else was working on the same incident, could I see what specifically they changed on that incident?
Okay, the way it's done, there's one owner per incident. So only one person can actually change things on an incident. Now, you saw I could grab ownership of the incident, and then I'm the only one allowed to work on the incident at that time. Other people can view it, but...
Right, at a later time, but if someone else takes control of your incident, can you see what they have done on it?
Yes, to some extent. There are two facilities for that. One, every time the incident changes status, it's time-stamped and with a little explanation why it's changed. And there's also a way to add comments and log what you've done so far in the incident. I guess it could be extended to be able to log every change with who did the change and what they changed. I guess nobody has requested it yet, but it's something that can be implemented easily. Yeah.
So the logging is not automatic then? If someone makes a change?
There's partial logging that's automatic,
Okay.
but it's not over the entire over all the fields of an incident. It could be if that's something that people wanted. Yes?
You said that only the owner of the incident can make changes.
Uh-huh.
Still, you changed the type of the incident to port scan, and you were not the owner. So.
Okay, bug alert. Right. I'll fix that. Yes?
In terms of the statistical information you're gathering, how much are you able to actually share between owners of incidents, since, for instance, there's a set of heuristics you were applying when you're up there going, well, there's no OS because it was on the network, whereas someone else might say for each machine that got scanned, they log a different incident. How much sharing can actually be done between two different operators, since without any, or are there guidelines that say you must log it this way in order to have valid statistical information to share?
Well, there's certainly a number of definitions you've got to agree on, and you've got to understand the classification that you're working on. It's not something for which the database has safeguards, really. There is a help page defining terms, but it's possible to make mistakes. And not agree, that two people do not agree exactly on what is the incident. Yeah.
I guess my question is, do you feel that it's valid to share statistics between two different operators, since there already is that difficulty in just agreeing on the basic terms we're using?
Well, by defining the terms first and having the classification fairly simple, I think that risk is fairly low.
Well, for instance, service theft is one of the things you had on there as a thing. How does that differ from account access? Where would you, I mean, I think probably if you asked everyone...
Service theft would be...
different definitions.
Right. Many people have different definitions for those, yes. So people using the database have to agree on the definition. Service theft would be, for example, I have access to an FTP server for work, and I decide to use it for my personal use, or maybe a company that I'm running on the side. So I'm stealing FTP service from where I work to run my Moonlight company, to help run it. But yeah, you're right. I mean, if people do not agree on the meaning of the terms, then the categorization of the incidents can be wrong. The only thing we can do about that is publish definitions and hope everybody understands the same thing.
Perhaps there's room for adding inline help next to the fields where you want to enter things.
Yes.
Ivan Kursel built decision trees for the vulnerability database that he built that were intended to precisely solve that problem, because you would answer the questions in sequence and follow the tree, and it will tell you in the end how to classify it. Maybe something like that could be.
I thought about that, and the solution I went with, because it's more work to represent a decision tree on a web page, unless you want to do graphics. I mean, represent them concisely. What I did is that I sorted them in order of which you should consider first. When you look at the types, when you're making it, no, I want to modify it so I can show you things. So for example, here, these are the ones you should consider in order, which would match a decision tree of the type that Crusoe will use. It's not exactly as good because it doesn't show the definition of the exact questions that you can look at when you use a decision tree. But it's the closest I could come to with poor man's HTML.
On the other hand, everyone who uses this is going to have some sort of introduction to the system. So you could print a leaflet with the questions or the trees that.
That's a good idea, yes.
They enter the information then.
Yes, thank you.
Well, thank you, Pascal.
Well, thank you.